Good morning students, myself Vaidehi working as Assistant Professor in Sri Muthukumaran Institute of Technology. Today the video lecture is from the subject EC 3452 Electromagnetic Fields for 4th semester ECE students. In this lecture we are going to see the topics from the Unit 3 Magnetostatics. In this lecture we will discuss about important magnetostatic concepts including magnetic boundary conditions, inductance, magnetic energy and magnetic forces and torques. These concepts are fundamental to understanding transformers, motors and other electromagnetic devices. First we see about the learning objectives. The objectives of this lecture are clearly listed here. By the end of this session, you should be able to explain electromagnetic field behavior at boundaries, understand how inductors work, calculate stored magnetic energy and analyze magnetic forces and torques. First we see about the magnetic boundary conditions. When a magnetic field travels from one medium to another, such as from air to iron, certain conditions must be satisfied. These are called magnetic boundary conditions. They are important in the design of magnetic circuits and electromagnetic devices. Next we see about the explanation of the boundary condition. There are different boundary conditions. The tangential component of magnetic field intensity may change if a surface current exists. The normal component of magnetic flux density remains continuous because magnetic monopoles do not exist. The normal components remains continuous based on Gauss law for magnetism. The magnetic flux lines form closed loops. Next we see about the inductance. Inductance is a property of a conductor or coil that opposes sudden changes in current. It depends on the number of turns, the material used for the core and the physical dimensions of the coil. Next we see about the self-inductance. The self-inductance occurs when a changing current in a coil induces a voltage in the same coil. Mutual inductance occurs when a changing current in one coil induces voltage in another nearby coil. Transformers operate using mutual inductance. Next we see about the inductors and their applications. Inductors are passive components used for storing energy in magnetic fields. Different types of inductors are available depending on the application. They are widely used in filters, oscillators and power electronic circuits. Next we see about the magnetic energy. When a current flows through an inductor, energy is stored in the magnetic field around it. The stored energy depends on both the inductance and the square of the current flowing through the coil. Next we see about the magnetic energy density. The magnetic energy density represents the amount of magnetic energy stored per unit volume. This concept is used in the analysis of magnetic materials and electromagnetic devices. Next we see about the magnetic force on moving charges. The Lorentz force equation explains the force experienced by a moving charge in a magnetic field. This principle is used in many devices including cathode ray tubes and particle accelerators. Next we see about the force on current carrying conductor. A current carrying conductor placed in a magnetic field experiences a force. This force is the basis for the operation of electric motors. The force becomes maximum when the conductor is perpendicular to the magnetic field. Next we see about the magnetic torque. Magnetic torque is produced when a current carrying loop is placed in a magnetic field. This torque causes rotational motion. Electric motors use this principle to convert electrical energy into mechanical energy. Finally, we came to the end of this lecture. To summarize, we studied electromagnetic conditions, inductance, inductors in magnetic energy, magnetic forces and magnetic torque. Hope you all understood my concepts. Next we see in the next video.